Hello student, myself Kinjal Mistry. I am lecturer in Computer Department of PPMP Polytechnic. In this video lecture, we learn deadlocks in chapter number 2, Processor and Process Management of Operating System subject, whose subject code is 330701 in Diploma Computer Engineering course. In this video lecture, we learn first what is deadlock, then condition for deadlock, then resource allocation graph, and last we learn dealing with deadlock. Now first, what is deadlock? A set of process is deadlock if each process is in the set is waiting for an event that only another process in that set can cause. Means here each process is waiting for some event. This event can be crossed by some other process for the set, but none of them will crush any event because all are waiting in waiting stage. No any process can come out waiting stage. All the process will continue to waiting forever. Condition for deadlock. There are 4 conditions that must hold for deadlock to occur. These conditions are as follow. Then first, mutual exclusion condition. Each resource can be assigned to exactly one process. If any process requests a resource which is not free, then that process will wait until resource become free. Then second, hold and wait condition. A process must be holding at least one resource and waiting for additional resource. Also, such resources are currently being held by other processes. Then third condition, no preemption condition. Resource cannot be promutable. Once resources are granted, they cannot be forcibly taken away from a process. They must be explicitly released by the process holding them. Then last condition, circular wait condition. This must be a circular chain of 2 or more processes. Each process is waiting for a resource which is held by the next member process of the chain. All 4 of these conditions must be present for a deadlock to occur. If one of them is absent, no deadlock is possible. Resource allocation graph. As described, there are 4 conditions for deadlock to occur. These 4 can be modular by using directed graph. This graph contains 2 types of nodes, process and resource. Process are represented by circle and resource is represented by square. Also, this graph contains 2 types of arc. First, an arc from a resource node to a process node. It is indicate that a resource is held by that process. In figure A, resource R is held by a process A. Then second, an arc from a process node to a resource node. It indicates the process is currently waiting for that resource. Then figure B. Process B is waiting for resource S. Such type of graph is called the resource allocation graph. It can be used to represent a deadlock. If resource allocation graph contains a cycle, it means there is a deadlock. Then figure C. Here process C is waiting the resource D, which is currently held by process D. Process D is waiting for resource U, which is held by process C. Both processes will wait forever. A cycle in a graph means that there is a deadlock. It involves a process and resource which make cycle. In one example, the cycle is CTDUC. Like figure C, resource allocation graph, then figure A, holding a resource, then B, requesting a resource, and C, then occurs the deadlock condition. Now, this figure A is represented process A held by resource R, then B figure request a resource, then C is represent the deadlock is occurs condition. Dealing with deadlock. No any system decide to have deadlock. There must be some means to deal with deadlock. In general, 4 strategies are used for dealing with deadlock. First, just ignore the problem. Then second, detection and recovery. Then third, dynamic avoidance. And fourth, prevention. Now first, just ignore the problem. According to this strategy, deadlock are ignored at all. It is assumed that deadlock never occurs in the system or it occurs on a rare occasion. This reason behind this is deadlock prevention risk is high. It is mostly in terms of putting a inconvenient registration on process. Most users want perfect and occasional deadlock rather than a registered access to resource. This is also known as stick algorithm. Stick your head in the sand and pretend that there is no problem at all. Unix operating system follow this strategy. Then second, detection and recovery. This strategy allows the deadlock to occur. It does not prevent deadlock from occurring. It periodically checks for deadlock. If there are present, take some action to recover from it. To detect the deadlock, a resource allocation graph is constructed, including all process and resource. If such graph contains a cycle, it means there is a deadlock. As system is deadlock is free, such type of checking is done periodically. To recover deadlock, there are 3 ways as described as below. First, recover through prevention. In case, it may be possible to temporarily take a resource away from its current owner and give it to another. If so, do it. Then second, recovery through rollback. Here some processes are rolled back to previous moment when there was no deadlock. This request periodically check positioning of process. Checkpointing a process means that its state is writing to a file so that it can be restricted later. For example, undo some transaction. It will free lock on database table. Then third, recovery through termination. The easiest way to break a deadlock is to kill one or more processes. One possibility is to keep a process in the cycle. Then third, dynamic avoidance. Strategy suggestion used to avoid the deadlock. This can be done by carefully allocating resource. When requesting come from any process for a resource, system will decide whenever a resource is safe or not, means whether a lead to a deadlock or not. Resource will be allocated only if it's self to allocated it. Then last, prevention. There are 4 conditions for a deadlock to occur if one of them is not present. Deadlock is not possible. Deadlock can be prevented by attacking one of these conditions. First is mutual exclusion. Share it, use the resource whenever possible, or if possible, resource can be spooled. For example, printed can be spooled. Here, one separate process is maintained which performs the print operation. It is called the printer demon other process. Requiring printing operation will request to this demon process and it do print operation behalf of those requesting process. This demon process never requiring any resource rather than the printer, so we can eliminate the deadlock for printer. Not possible for all resource. Hold and wait. It required that all process should request all the resource at the beginning of execution. If everything is possible, process will be allocated whenever it need. Then it can run completion. If one or more resource can be busy, nothing will be allocated and the process would just wait. This problem here is that it's difficult to determine in advance in resources are required in execution. Now third, no prevention. Normally not possible because the non-promotable resource like printers cannot be permitted. Then fourth, circular wave. Here resources are allocated in some fixed order and it is assumed that there is no cycle in according resource. Thank you. Thank you so much for watching this video.